Hey scholars, welcome to chapter 2-3, and we're also going to cover 2-4. Today we're looking at how can matter change and also what is energy and how can it change. That's what we're going to look at with this next segment. So there's obviously some different changes that can be undergo. The first one is physical and chemical change, and then nuclear change. Those are our major three. The physical change is something simple, like if I had a sheet of paper and I ripped it in half, it's a physical change. It's still paper, it's just been changed a little bit as far as the way it looks. Chemical change would be like if I actually had a lighter and lit this thing on fire, that would end up being a chemical change. You're rearranging the molecules into a different form. Nuclear change is a little bit different. It has to do with radioactive decay, fission, and fusion, and it has to do with radioisotopes that are unstable and trying to become stable, and that's where we'll start with these. We'll look at each of these three types of nuclear changes. The first one is radioactive decay, where literally an unstable isotope is trying to become more stable by releasing particles. There's three particles that can be released: alpha particles, gamma particles, and beta particles. Again, those are some of the different things. Now, those can be damaging to us. Some of them more damaging, like gamma rays rather than alpha rays, but that's radioactive decay. Another nuclear change can be nuclear fission, literally where a neutron is fired at an isotope, and when it does that, it starts a chain reaction where it releases lots of energy. This is the major reaction we use in most of our nuclear power plants. Nuclear fusion is an awesome theory and a great idea, but unfortunately it's hard to get anything to be 1 million degrees Celsius, so it's very hard. We've actually never done it, but it would be a major source and a perpetual source of energy. This is what the sun uses. So it's kind of interesting. Those are our major three types of nuclear changes. And the last thing we'll look at with this little section is the law of conservation of matter. You know, matter cannot be created or destroyed. We've heard that before. And matter consumption. Matter is always converted from one form to another. It's not really lost, it's just changed. And that's the gist of the law of conservation of matter. We're going to skip ahead and talk about what is energy and how it can be changed. And one of those, there's two types of energy. There's kinetic energy, which is like heat transferred by radiation, conduction and convection. Electromagnetic radiation is another type of kinetic energy, and all those are kind of energy in motion and movement. Potential energy is usually stored energy. It can be changed to kinetic energy if acted upon with energy. So those are our two different types of energy: potential and kinetic. And this is one of our kinetic energy, looking at energy emitted from the sun, looking at different wavelengths. Energy in this case is transmitted by wavelengths, and the variation of wavelengths cause for different, again, types of light: visible, ultraviolet, and infrared. The second law of thermodynamics in living system we'll get to in a second. This is kind of the gist of how energy moves. It starts with solar energy. There always is some waste as heat. It's still energy. It's just one that we don't really are using as organisms. Chemical energy, which is through photosynthesis by plants, again, still lost as some waste heat there. Transmitted to chemical energy in food through the mitochondria within plants and animals as we eat them. And then again, still wasting as heat. And then we change that into mechanical energy, or moving, thinking, living, growing, things like that. Obviously, he's using to dig and plant more trees, and the trees growing still as well. But in all of that, we still waste heat. So it leads us to our second law of thermodynamics, which energy is not transferred with 100% efficiency. We're going to get to this a little bit later, and there are some different types of energy: high quality energy as well as low quality energy. And again, higher quality energy means it can be transferred and still has a lot of energy potential to it, and we can get a lot out of it. Low quality is usually down the line after it's been converted a number of times. So first law of thermodynamics: energy input always equal to energy output. Going back to this image, this is still equal in energy. It's just transmitted in a different form. Second law of thermodynamics: that energy always goes to a more useful in the beginning to a less useful form after it's been changed and converted from one form to another. So it's not transferred with 100% efficiency. It is, there is some loss there as heat, but it is still energy. It's just one that the organism being transferred to can't use as much. Energy efficiency or productivity, again, this all leads to that. We'll get into more energy stuff when we get to chapter 3 and 4 coming up here in another week or so. That's a quick lesson for that. That kind of brings us to a close here. Almost. Our next lesson will be on something new for you: what are systems and how they respond to change. So we'll see you next time for that lesson.